Okay, good morning everybody, and thank you very much for the opportunity to be here and to talk to you today. I'm here to talk about an exciting project in the GSQ called the Geoscience Data Modernisation Project and share some of its detail. However, I really wanted to start right at the beginning and touch on some of the key drivers for this project and why it's so important that we actually do it. We are all at the moment part of a massive revolution, the big data revolution. And it's having a profound effect on the way that we incorporate data into our business decision making. Data and information is a subject which has been very close to my heart for a number of decades now. And what I've been seeing, particularly over the last few years, is organisations are really starting to value the data that they hold. And they're making moves to exploit that hidden value. Data has become the new currency of business. Just ask Facebook and Google. They rely on all the data they collect from consumers to drive their advertising business, as well as develop new business opportunities. And they, probably more than anyone, are responsible for this massive change we're seeing. And just like other business domains, the geosciences is also primed to take advantage of this new era of change. So what's driving this revolution? Well, cheap internet connectable sensor technology is one thing. We can connect sensors to just about anything these days and develop a data stream from that. There's been a massive connectivity jump in the internet. From 2005 there were about 1 billion users on the internet. Now there's 4 billion users. All of these people using, creating, accessing data and information. And I guess the other thing that's really important to acknowledge as well is there's been a huge organisational culture change to much more open sharing of data and information. And this has resulted in access to massive amounts of data and has really coined the term big data. Just a few statistics that give us some sense of the magnitude of this change. 90% of the world's data has been created in the last 2 years alone. Most companies only analyse 12% of the data they have, and I'd like you to hold on to that thought through this presentation because that's a fairly important observation. There'll be 50 billion smart connected devices in the world by 2020. 50 billion. And poor data quality costs the US trillions of dollars every year. And that Internet of Things, that sensor technology that I was talking about before, it will save consumers and businesses $1 trillion a year by 2022. So the magnitude of this change that's influencing both our business and personal lives is unprecedented. But it's not just about collecting data for data's sake. This large-scale data access supports the capacity for large-scale analysis. It's not just about data resolution. It's not just about being able to see things in finer detail that we can already see. It's also about finding relationships between different data sources. The analytics plus data allows us to see new patterns, not just see the existing things that we know of better. Humans can manage about 6 relationships at a time, whereas computers can manage thousands or millions. These patterns and correlations are the gold that we're actually mining for, if you'll excuse the pun. And because these relationships and patterns lead to insight, and in the case of geosciences, this insight could lead to the next big discovery. So access to data and analytical techniques is driving significant improvements in many other domains, and I'll just touch on a couple of examples here that are quite significant to give you some perspective of how wide this change is. Breast cancer, it affects 117 out of every 1,000 Queenslanders every year. What if I was to say to you that we could increase detection rates a further 16% by just using the data we already have much more effectively? Or, from a logistics and transport point of view, if we could save 10% of a $1 billion budget every year just by collecting and using data more effectively as well. Well, this has happened and is happening in the US. Google Analytics have improved the breast cancer detection rates from 73 to 89% in the US, just using their existing data and information. And Norfolk Southern, which is a US rail provider, have optimised its network by placing sensors on its rolling stock and using machine learning, and they're saving $200 million a year. So it's a big deal in other domains as well. So what does this mean? What does this have to do with geoscience? Well, the key point here is the big data revolution is driving change in the geosciences just like it is in many other domains. It's driving even greater focus on the use of data in exploration. Now, data in exploration has always been very important, but it's really pushing a much increased focus on data and the importance of data to exploration programs. It's about getting insight from old data. So a lot of geoscience data doesn't typically go out of date, as we know. So it's about being able to use data that's decades old and include that in new analyses. It's also about it's also about leveraging big data analytical techniques for geoscience problems. So a lot of the analytics that's happening in big data and a lot of the exploration that's happening is really applicable to the or can be moved across and made applicable in a lot of cases to the geoscience problems that we have. Data and insight is also underpinning our decision making so that we can make better decisions as well. So in turn, this is driving change to improve the accessibility, quality and reusability of our existing data and information, and this is to fuel our analytics programs much more effectively. So this has already been embraced in the geoscience world, and I did a quick Google search and just came up with a couple of things here. There's a company called Goldspot Incorporated in Canada, and they managed, using a machine learning model and data, they managed to find 86% of the existing gold deposits in the Quebec Abitibi, but they only needed 4% of the surface area to do so. It's a fairly impressive statistic. There's also a large amount of interest and with startups and new companies coming online that are developing machine learning solutions that generate precise exploration targets for previously unexplored areas, and Earth AI is one example of that. There was another one I found called Orfox as well. The key point of this is that this access to both novel data sources and this analytical power gives us the ability to explore more challenging areas. This is especially when the potential target is undercover. So success requires smarter ways, not only in redefining how we use the data, but also how we manage and curate that data to ensure it can be used for geoscience problem solving, because 80% of the effort in doing this is in data management. So for the GSQ, the Geoscience Data Modernisation Project is that smarter way. So what is GDMP? So GDMP is inextricably linked to the GSQ strategic direction. So the GSQ's been through a lot of change in the last few years, and it sees its role now as enabling disruptive change and being able to foster innovation, but also has a much greater focus on the importance of data in driving that innovation. Leveraging the technological development coming out of this big data revolution is key to that change, and this is to drive a data-driven decision-making culture in the organisation. The GSQ mission is around focusing our skills, technology and data to enable industry success. And GDMP supports that vision by making every possible piece of GSQ custodial data available. So how does the GSQ support a data-driven exploration culture? Well, there are 4 key pillars which make up the GSQ approach. The first is around data ingestion and ensuring that we have robust processes and procedures for the way that we accept data. And we've currently got some minerals and coal as well as petroleum guidelines out for consultation at the moment. And that's about streamlining and standardising the way we're accepting data so we have improved quality on the way in. There's also a data curation piece which GDMP fits squarely within, and it's about ensuring that we have a robust management environment for our data and our information, and that we can find that data and information very easily, and people can download and access it. There's also the value add, and I've alluded to that, around analytics, insights and intelligence, and we're developing capabilities in that space slowly. And there's also clearly a piece around industry enablement, and it's about the GSQ building skills and the capacity through a heap of collaborations both with industry and with academia. So what are the current challenges that we face? Well, currently it's difficult to find all the geoscience information that exists for a particular area from the GSQ. Industry can't access all of our data. Our quality is highly variable at the moment. We can't unlock the value of that particular data, and the cost of maintaining our multiple systems at the moment is really unsustainable. Our current state is that we accept data in a lot of our data in structured PDFs, and it's very difficult to get that data out of. We have multiple fragmented data stores, and we have a lot of manual extraction and manual data management methods. We want to move to a situation where data is itemised and well structured, where we validate data at point of entry. We have single points of truth for both of our data and our metadata. We have almost all of our data, all of our open data, available online. And we offer data services in the sense that we can offer data services in the sense that we allow people to connect to our data directly through APIs, not just being able to download the data to their own machines. We have significant risk in our current systems at the moment. Our Merlin system is now 31 years old and it's on unsupported technology. It's also accessible only by internal users. We also have a lot of duplication and expensive data storage associated with these systems. So we're moving to a data lake paradigm at the moment, where we have a single point of truth, which is based in the cloud. It has high availability and accessibility, and everything is stored in one place. This slide broadly outlines what the GDMP future state architecture will look like. We're going to establish, and we have established, a data object store where we store every piece of data as an object. We have an index of all digital and physical data, which is our data catalogue. We have an access engine which allows both human and computer connection to that particular data. We have a data processing engine as well, which optimises, enhances and cleanses our data. And we have over the top of that capability to visualise and do data analytics so that we can help industry find insights in the data that we hold. The data catalogue is pivotal to our success, and it provides us with a number of key capabilities. The first is around the fact that we're moving to standard schemas for all of our concepts, so we have consistency in the way we're describing things. We're moving to standard vocabularies to actually describe those concepts, so we're using the right language and a consistent language in the way we're describing those concepts. We're moving to persistent identifiers, which for all of our data objects and all of our samples, so that we can unambiguously identify and find things. And we're moving to a linked data model, where we can connect related data together that wasn't previously linked before. So there are huge benefits to be able to better link data together. The ability to map and define relationships between disparate data sources enables us to encode meaning in our data. And at the moment, the only way you can link these concepts together in the GSQ is if you spend a lot of time collating the data through a heap of database joins. And in fact, you have to be an internal user as well. So a linked data model allows us to traverse the data. So we could pick a permit, see all the boreholes on a permit, and then reports for the boreholes, et cetera, et cetera, et cetera. So this approach is about data discovery, and it really reflects how we think about the world naturally. And the great thing about taking this approach is we can infer relationships. So in this particular example with the green arrow, we could potentially find out what assay data belong to a particular permit or permit holder, which is something we can't do at the moment very easily. We're also establishing a pilot capability, and the GDMP industry pilot will be released on June the 30th. It's going to be focused primarily on seismic and geochemical data. There's going to be about 800 plus seismic surveys, but we're working really hard to get the whole seismic archive up there that we have. And there'll be a complete geochemistry database offered. Users will be able to search for and download data from this capability. And it's a fantastic feedback opportunity. The primary reason we put the pilot in place is to get feedback from you, industry, so that we can ensure the solution we put in place really meets your needs. So I'd really encourage people to get involved with this particular program. So pilot progress to date, and we've done a number of test and learns around this, and I'm just going to touch on a couple of things pretty quickly. We've established and tested a draft EPM form to test whether we can actually ingest data from outside into our central data store, and that was successful. We've established a test form for data entry, which validates the data at time of entry, so people entering data into a form can basically enter that data in, it gets validated at point of entry. This is to improve our data quality standards and processes on ingestion. We've stood up a pilot data lake in the cloud using Amazon S3. We've established and tested a base catalogue architecture using CCAN as well, so we have a basic catalogue function in place at the moment. And we've established a file gateway which allows GSQ to load data into our cloud-based repository. So why is GDMP different? And I've talked a lot about standardisation, but it really is about that, a lot about that. It's about standard representation of concepts. It's about linked data structures and having those standard based, so you can traverse the data, you can connect data together, and you can get a better understanding about what it's telling you. It's about controlled vocabulary, so we're using consistency in the way we're describing all of our concepts. It's about having quality metrics and quality assurance around the data that we actually provide, so that you've got some idea about what the quality of the data is that you're consuming. It's about the provenance of data being recorded, so that you have an understanding of how much you can trust that data in your analyses. It's about having a single metadata repository, a single data store, a universally unique persistent identifier, so objects can be unambiguously identified. It's about having metadata in a database and data in an object store. At the moment, they're a little confounded, and it creates a lot of confusion. It's about having an open system with a federated search. So when you do a search over an area, you get all the data that GSQ holds for that particular area, not just some of it. And it's designed for both humans and computers, so we can actually you can connect your systems directly to ours and our data stream. From a technical standpoint, for us, it's about low cost, high volume of storage. I've talked about inference in terms of relationships. It's also about schema on read, and this is about loading data the way that it comes to us, and then letting users make decisions about what schema might be most appropriate in terms of their particular application. It's also a vendor-neutral system, whereas our current system stack has vendor lock-in, which is creating a lot of problems for us. And we can store structured, semi-structured and unstructured data within that. So in the end, it's all about having every data object described by metadata. The metadata is validated against a control vocabulary. This results in a high-quality data catalogue and data store with integrity, which leads for easy data discovery. So from an opportunity point of view, from the GSQ's point of view, the opportunity here is for us to optimise our geoscience data ecosystem, the people, the process and the technology, the full stack, to unlock the full value of data to enable exploration success. Thank you.